Welcome to Spring LIB.
Okay, so we're talking about how simple dienes absorb in the ultraviolet region. However, as those dienes get longer, or sorry, not dienes, but as you get longer and longer conjugated systems, they will start to absorb uh, in the color region, right? So we're talking about simple dienes like this, ultraviolet, and then long um, longer chains start to move into color. Okay, well, recall, right, that uh, dienes can be modeled, or their behavior can be modeled via the particle in a box um, sort of conception, right? Where, for example, if we talk about a one-dimensional box, right, an infinite potential well, that the length or size of that box influences the energy at which uh, electron absorptions occur. In particular, the energy of the absorption of an electron in a one dimensional particle in a box is proportional to 1 over the length of the box squared. Right? So there's a bunch of constants that come out front that I'm putting here in K. Like, for example, you end up with an 8 in the bottom. The mass of the electron is part of it. Planck's constant. But ultimately, it's a bunch of constants multiplied together. And really the only variable in the equation of an electron absorption in a particle in a one-dimensional box is the length of the box. So given this uh, uh, dynamic, right, then we can see that the size of a one-dimensional box, right, is proportional to the energy of electron absorptions in that box. And in fact, dienes can be modeled as one-dimensional or two-dimensional particles in a box, depending on their properties. And so what you would see here is that as length, whereas L goes up, energy, the energy of transition, goes down. Right? And if you recall, when you're talking about the electromagnetic spectrum, right, if this is our region of color, and we're saying high energy over here, low energy over here. You could also talk about it in terms of wavelength and say low wavelength over here, long wavelength over here, or low frequency, high frequency. Okay, energy and frequency are proportional. Wavelength and energy are inversely proportional. The idea is that in terms of energy, we'll have color here, and to the right is our UV, right? And to the left is our IR. Okay. Up here is violet, blue, right? And down towards the left is our red, orange, and yellow. Red, orange, yellow. Okay. So what we're seeing is that as N increases in our conjugated dienes, meaning we add more and more of these double bonds and lengthen the chain, that the color goes from ultraviolet, when N equals 2, goes to yellow. When N equals 5, it goes to orange. When N equals 8, it goes to red, right? Basically, that's saying that as the length of the chain increases, the energy of the absorption of electrons in that system decreases. Right, so that's the explanation. And you can explain that by noting that dienes, electron absorptions within dienes behave like the particle in a box model in which the energy of the transition is inversely proportional to the length of the box.